Unleash your curiosity. The 2021 Wisconsin Science Festival. Hybrid, hands-on, and virtual. Events throughout Wisconsin for all ages. Discover the wonders of science and the power of knowledge with a focus on fungi with scientists, live Q&A sessions, science experiments, and more. Plus, PBS Wisconsin Education launches 2 new interactive labs in the Meet the Lab collection. Full schedule at wisconsinsciencefest.org. Curiosity Unleashed.
Greetings, fellow scientists. I'd like to welcome you all to the Wisconsin Science Festival online field trip, exploring a climate change solution, making green fuel for the future. Thank you for joining us today. We're ready to get started. My name is Gerard Buckner from the Wisconsin Science Festival team, and we're here with our special guest, Samara Hamzi. I'm sorry if I mispronounced that. And Gina Smith for this field trip experience. How can you participate today? You'll notice there is, you'll notice that your picture and audio are muted, but if you have any questions you'd like to ask, you can use the Q&A feature or the chat. As soon as you have a question, go ahead and type that in right away. We'll ask your questions for you out loud during the field trip. We'll let Samara go ahead and get started. If you'd like to introduce yourself and speak a little bit more about your organization and your energy education. And then as you're going through, if any questions pop up while in the middle of a certain topic, I'll interrupt and ask those questions, and we'll go from there.
Perfect. Well, thank you all so much for joining us. Are you hearing me okay, Gerard?
You sound perfect.
All right, excellent. Well, thank you everybody for joining us for this Wisconsin Science Festival virtual field trip. I am an energy educator at Wisconsin's K-12 energy education program on the campus of UW Stevens Point. And I've been asked to share with you a little bit about my journey to becoming a scientist. But before we begin, I'd like to recognize that the University of Wisconsin Stevens Point occupies the lands of the Ho-Chunk and Menominee people. If you could please take a moment to acknowledge and honor this ancestral land and the sacred lands of all Indigenous people. Thank you. So my story begins where I grew up. I grew up in the country of Lebanon, which is located at the eastern end of the Mediterranean Sea. It's a really small country. You could fit about 16 Lebanons in the state of Wisconsin, or 4 Dane counties in Lebanon. I lived in a city about the size of Milwaukee in an apartment building, and here I am in 4th grade standing on the balcony of our house with my dad. I attended a neighborhood private school. It was an all-girls school. You can see we wore uniforms, and here I am on a field trip. Lebanon is a really ancient country as well. It has had humans populating it for thousands of years. So there's layers of human history there. You can see the architecture there is very old, but in that architecture, you can also see some modern technology going through. There's electric wires that are strung through, but they aren't in conduit tubes. So it's really, really obvious. And one of the unique things about growing up in Lebanon when I did is that that country's civil war was taking place. And as a result of the war, and there's wars still happening all over the world, as you may know, there's a huge disruption that happens both in the political world as well as just how infrastructure is managed. So roads weren't maintained, water distribution and collection are disrupted, and so was electrical distribution. And so this is not just a unique example in that neighborhood. If we take a look here, this is a very common sight to see a breaker box with just colorful spaghetti coming out of it. So this is electricity going to people's homes. People splice off of other people's power to get electricity to their homes. So how power is generated and how it is distributed is a really personal story for me. And as a result of the war, when I was 12 years old, we suddenly found ourselves in the United States. So many people are displaced by war, and I am among those. I finished high school and went to college at the University of North Carolina, Chapel Hill. In my senior year, the men's basketball team won the NCAA men's championship, and I am still a huge basketball fan as a result of going there. Also in my senior year, as part of the requirements of my liberal arts degree in international studies and French literature, I was required to take an environmental science class. And I kind of rolled my eyes like, oh, I don't really want to do this. I'm a French major. Why am I here? But actually, it was in that class in my last semester that I discovered what I really love, the intersection of science and society. So I graduated with those degrees, but then for my master's, I switched and I studied plant ecology. I did my research on the shores of Lake Michigan, which you can see in the background here. And I was studying a rare plant, a rare thistle that only occurs in the Great Lakes called pitcher's thistle. And you can see me with my field crew here. I actually continued doing that research for the next 25 years. Some of the equipment we use are metal detectors. We use clipboards for collecting our data because computers, as good as they are, still do not hold up well in sand and sun and water. We also have 100-meter field tapes and flags that we use to identify our plants. And while doing my research, I found really what I love. I just fell in love with the Great Lakes. I fell in love with collecting data and sharing data about ecosystems. And it's from that work that I really found my mission in sharing information about our planet so that we have the information we need to protect it. So I'd like for you to either put in the chat or to consider what is something that you really love that you might want to turn into a career. And Gerard, if there are any answers coming in that you'd like to share, I'd be happy to hear them. Oh, you're muted. I'm sorry, I can't hear you.
You would think I would know how to do this by now, but I guess not. Oh, we got one answer, science, just science in general.
Mm-hmm. Great. Yeah, and you might notice from what I was doing, I switched from doing something in literature to doing science. So you might not know what you want to do until later on, and that is totally cool. It's great to learn and make decisions as you go along and find what you're passionate about.
Our participant says animals. Animals,
yay. I struggle with animals, they move, that's why I studied plants. Okay, well here we are. I'm going to give us an overview here of our field trip. So first we're going to take a look at the fact that data are all around us and explore some of those data. And then we're going to focus in on a particular kind of data, and that is energy data and how we use energy in society. And then building off of that, we're going to think about how we have solutions in the world around us, and you as students and all of us as members of society, how we can address our energy use by some of the decisions that we make. And then finally, I'll suggest some ideas for students that where you have the ability and the power to make change in your own community when it comes to how energy is used, and you can really affect the data both on climate and on energy. So we're going to start off here. If you take a look, you can see that we have some kids who are playing tag. The girl who's seated is already tagged out, and the child in the front in the foreground is it. So that person needs to collect, analyze, and act on the data available to them really, really quickly. So some of the data they might be collecting is past data, like who is my friend and who is not going to tag me back next time we play. But it also could be data of who is closest and who is fastest. So from the time we're very little, we are collecting, analyzing, and acting on data. So think for a moment, what are some data you might have collected and analyzed and acted on today? And I want to suggest how you got dressed this morning, or what you perhaps had for a breakfast or had for a snack might be some of that data that you collected, analyzed, and acted on. Here's another example of data that are just in the world around us. So this is a scenario of the Packers are going to the playoffs, and we certainly hope that is the case, right? Playoffs happen in winter, but and your family gets really lucky and you luck into some tickets to go to a playoff game. But to make the decision of whether or not you're going to go as a family, one piece of data you might need to analyze is, well, there's COVID. So is it safe to travel? What are the rates of COVID in the county where you're going to, the county that you're in? and your family decides to go, you're driving there, it's winter. So decisions that are based on what are the road conditions. We're also being given feedback as we drive along from our environment. Some of it is digital, some of it is from our experience and we're observing it with our eyes. We have other data. So your parents are driving a car and they're looking to see how is what is our speed? Are we driving at a speed that is safe for the road conditions? Do we have enough time to get there? Another piece of data, you get to the game and there's data coming at you from the scoreboard that is up there. How are the Packers doing? Another piece of data. And then you're sitting there thinking, all right, well, I'm at the game, but I also need to be thinking about school. So maybe you have the data of what are the college acceptance rates? When should I be taking the ACT or the SAT? And you're doing this on your phone and your adult leans over and collects their own data, says, what are you doing on that device? How long have you been on there? We're here to see the game. So we have data around us all the time where we're collecting the data, analyzing the data, acting on the data. Data really are everywhere. So we've seen that those data are everywhere. And now we're going to go in and start exploring some of the energy data. We're going to collect some data together and then analyze it in the next section, solutions. So here's our first piece of data. If you think back to the Packers example, each of the pictures in the Packer playoff scenario involves the use of energy, often as a result of the combustion of fuels. And one of the byproducts of combustion are emissions. So we use fuel to make electricity, either by burning natural gas or coal, or sometimes we produce electricity as well through hydroelectric dams, as well as renewable energy and nuclear. We have emissions that are a result of the food. The food, if we take the Packers scenario, you're eating food at the stadium, you ate food on the way there. Industry would be the industry that it took to build Lambeau Field, that it took to build the car, to manufacture the car that your family is traveling in, the transportation of getting to the game. The building is the actual Lambeau Field, thinking of the scoreboard. It takes energy, it takes electricity to light up that board. And your home is lighted and heated or cooled with using energy as well. All of these sources here result in emissions that go up into the atmosphere. And these emissions are often carbon dioxide and other greenhouse gases. So greenhouse gases, you may know what they are already, but here's a quick definition. They are gases in the Earth's atmosphere that trap heat. They let sunlight pass through the atmosphere, but they prevent the heat that the sunlight brings from leaving the atmosphere. So those are our sources of greenhouse gases that go up into the atmosphere. Fortunately, we also have sinks, so places that those emissions can get trapped so that aren't stuck up in the atmosphere. And our sinks are land sinks, so plants, trees and other plants, as well as agricultural sinks that there can be, as well as our freshwater and saltwater oceans because of the algae that are there that are photosynthesizing. But about 59% of our emissions stay up in the atmosphere. So that's our first piece of data that we looked at. The second piece of data that we're going to be collecting, and you may have already had the opportunity to look at this animation before coming to the workshop. If not, the link will be shared with you to look at afterwards. But our energy use from the early 1800s to the current day has about tripled. And so the units in which we're looking at energy use is watts per capita here. And how we are using energy today, it's about a third of our energy use per person is based on the buildings and homes that we occupy. A third of it is the stuff we use and the food we eat. And about a third of it is how we and our stuff and food get places. So it's fairly evenly distributed among those sectors here. But in our homes and our buildings, so think of your school buildings, think of buildings where the grocery store or other places you might go. Electricity is a large component of our energy use. And again, electricity is about a quarter of our sources for emissions that go up into the atmosphere. So now we're going to be collecting our third piece of data. And for this one, you really are going to have to collect some data. So this is a very famous curve known as the Keeling curve, and it's based on the research of Dr. Ralph Keeling, who beginning in 1958 started collecting carbon dioxide concentrations in the atmosphere on a daily basis on Mauna Loa in Hawaii. And so on here, we're just looking from the beginning of that data set to the current day. And on the y-axis is the carbon dioxide concentrations, on the x-axis is the year. So this year in 2021, it's about 413 parts per million. I'd like for you to find your birth year and figure out what the carbon dioxide concentration was in your birth year. So to give you just a bit of a hint, if you're in 6th grade, you were probably born around 2010. Carbon dioxide concentrations were around 390. So go ahead and find that. All right, hopefully you've had a chance to jot that down or notice it. I was born in 1971, and the carbon dioxide concentrations then were 326. So it's gone up 90 parts per million over the last 50 years. And maybe you might be thinking, well, maybe it's normal. I mean, it just looks like a pretty smooth curve going up. So we can actually look back in time. The accumulation, so this is the Keeling curve that's dark here, the accumulation of carbon dioxide and other greenhouse gases is happening at an unprecedented rate. You can see this part of the curve is really sharp. What we have preceding that is data that scientists have found by taking ice cores and looking at tiny bubbles of air that have been trapped in ice. And they can date when that air was trapped in there and look at the carbon dioxide concentrations. So beginning in about 1700 to the middle of the last century, it was fairly level at about 275 parts per million. And then as the Industrial Revolution began, it starts picking up. And then post-World War II, we have an unprecedented rise of carbon dioxide in the atmosphere. And you have the opportunity, you can look back. We actually have data dating back 800,000 years as well that you can explore. So here's our first poll question, and I think that our hosts are going to put it on there so you can actually give an answer. And the question reads, what percentage of scientists agree that climate change is caused by humans or anthropogenic? And Gerard, as you're ready and see answers coming in, if you would like to close the poll when you feel it's the right time.
Yeah, no, absolutely. As of right now, we got 80% going with 66% as the answer.
All right. Well, you're in the right neighborhood, but the correct answer is 97% of scientists agree that climate change is caused by humans. And so I have a link that will be shared with you or your teacher that you can take a look at that. So we have more or less scientific consensus that climate change is anthropogenic. Thank you so much for participating in that. We're going to have 4 poll questions total here. So I want to just recap what we've talked about here. We've so far collected 3 bits of data, that we have sources and sinks for our emissions, and they pass through the atmosphere and then come down into sinks, but we have a large portion that remain up in the atmosphere, that our energy use in the United States has tripled since the early 1800s. And we've seen from the Keeling curve that atmospheric carbon dioxide concentrations have been increasing at an unprecedented rate. So we've been collecting data, but we still don't have enough data to act, because the data we've been looking at are at the global scale and at the national scale. And we really need to bring it down to a scale that you and I can act on. So I have a second poll question here. I'd like for you to take a guess. In 2012, I need to move that off my screen. There we go. In 2012, electricity accounted for what % of energy usage in education buildings in the US?
I'll bring those answers on in. Here we go. Let's see. We got 20% saying 24. We got 40% saying 48. Oh, change some more. We're two-way tie between 48 and 54 at 33%.
Excellent. All right, so we I'll show you the next slide and we'll look at what the answer was. So 54% of our energy use in education buildings comes from the use of electricity. So education buildings are the buildings you use as students. These are schools, as well as at universities, the buildings that are there. So that's a really key bit of information. And we get this data from the US Energy Information Administration. And while we're looking at 2012 data, these are really big data sets that take a long time to analyze. So we're not going to actually see more current data until later this year. And if you'll remember, what we are looking to do here is to we need to find solutions to the concentration of carbon dioxide in the atmosphere. We have to combine reducing our sources and supporting our sinks. And so for the rest of this field trip, we're going to look at reducing the sources when it comes to electricity. So school buildings have over 50% of their energy use comes from electricity. We can either shift production, not either, we have to do both of these things. We have to shift production, so getting electricity from sources that do not come from combustion of fuels, and make our buildings more efficient. So not losing the warm air when we're heating the buildings or the cold air when we are cooling the buildings. And also preventing the buildings from taking on as much heat if a building is facing if windows are facing the sun, closing the shades. So there are things we can do as occupants of those buildings to make the buildings themselves more efficient. And so for the rest of this field trip, we're going to be looking very specifically at shifting production of electricity for school buildings. And I really take encouragement from this quote here. You can read it for yourself, but what I learned from it is that no one person can work on all of the solutions. We can't fix everything individually, but we can work together towards a solution. And this is from a really beautiful book written by Dr. Steingraber. I encourage you to read that if you get curious about that. And the key phrase in there is, you are not required to play a solo. We aren't each of us having to fix all of the problems. The problems are big, caused by lots of people, and the solutions can be also brought about by lots of people working together. So let's talk about solutions and using your school building as a solution for climate change. So here's our third poll question. Take a guess. There are about 3,000 school buildings in Wisconsin, K-12 school buildings of public and private. How many of those schools have photovoltaic installations?
%, says 50.
All right.
There we go.
I can't wait to share the next screen then, because everybody's wrong. And that is the best wrong I've ever had. You guys are going to be really happy with being wrong about this, because we have 226 installations in 52 counties for a total of 12.56 megawatts of installed PV on our schools. Each of these dots, unless it has a 2 or 3 in it, represents installations on a K-12 school. So there's a lot of installations that are there, but we actually need to start analyzing the data. So we've collected a whole bunch of data, and now we're drilling down and beginning the analysis here. So the team at Keep and myself found that although we have 226 installations, those installations are only producing enough electricity to offset 3.6% of the consumption. So we have over 94% of the electricity used in buildings is still coming from fossil fuels. And so we really, that is not 100% true, because some of the electricity coming into schools is also coming from hydroelectric dams and nuclear. But a very, very large percentage of that 94% is coming from the combustion of fossil fuels.
Tamara, we have one question.
Yeah.
The question came in and said, who pays for the solar panels on the schools?
That's a really great question. There are a variety of strategies for doing that. Sometimes it's usually a combination of schools getting grants. There's also incentives that come from the government. So when a school district works with their focus on energy advisor, they can get grant money or get deductions that come in there. And then also the money saved by a school district because they're producing their own electricity over a period of time ends up paying for the panels themselves. So it's a combination of financing strategies that allows for that to happen.
That's interesting.
And I would love to take, somebody can email me later and I have a lot of information on that.
Awesome. Thank you.
Yeah, thank you for that. That was a really excellent question. So we're looking here again that we have 94% of electricity used in schools. It presents a huge opportunity for you as students and schools in general to be a part of the solution. And so these solutions are happening. In Dane County, there's the Dane County Youth Environmental Environmental Committee that is a coalition of students from 15 high schools in Dane County. And they're working on a variety of strategies. Like in McFarland High School, they're working on minimizing waste because waste is a source of greenhouse gases. Monona Grove High School will soon be getting solar installations that is going to offset the full use of electricity in that school building. And in Middleton Cross Plains School District, they've recently passed a sustainability resolution that for the long term gets the school board and the school district thinking about how that school, all the schools, not just one building, but all the schools in the district are using energy, where they're sourcing their food, how transportation happens, and so on.
There's a couple more questions that actually came in.
Yeah, great.
One from Joe is there any coming from wind power?
There are, yes. So most of the wind that is supplied to schools is coming from the grid. So most of the wind energy in Wisconsin are from large installations that are owned by utility companies. So I can give information on that, but there are maps of wind installations that the student can Google and find as well. And there are a few schools, but not many in Wisconsin, that do have their own wind on site, but it's not offsetting the full use of electricity for that school. That's a great question. And there was another one? Yeah,
from Christopher, they said, are there schools using other alternative methods for energy production, such as wind or geothermal?
So I just answered the question on when there is a bit of that. Geothermal, there are some schools that have that, and we have a little bit of data on that as well. It is definitely not as common as solar is, though. And I'm in this talk, I'm more focused on solar, and we do have some data on that. And there are definitely some newer school buildings that are being constructed that have a combination of geothermal and solar together, so that for a net zero building. And an example of that was the newly opened Forest Edge Elementary School in the Oregon School District that opened last school year.
Awesome. Thank you.
Yeah, those are great questions. Keep them coming. I love it. Challenges me to think hard here. So this is a map that we have, that we host at KEEP, and we are actually in the process of updating it, because there will be more blue dots on here. But each blue dot represents a school with a solar dashboard. And a solar dashboard is essentially a website where anyone can see how much energy is being produced by the solar panels at the school. Not all dashboards are public facing, so that's why you don't see as many blue dots on this map as the previous one with the red dots. And for next few slides, we're going to look at Eau Claire schools and explore what's happening there. So Eau Claire has two high schools, Memorial and North High School, and their students, working with the broader community, helped raise funds so that those schools could each have 126 kilowatt solar system installed at them. And their systems just came online in December of last year. And they're relatively large systems that produce enough electricity to power the equivalent of 32 homes, and are going to be saving each school about $20,000 a year in operating costs. Here's a picture of the installed system, and you can see it's winter time and that it is also COVID time when this all happened here. The link was shared with you or with your teacher to be able to view the dashboard in real time. So if you have access to the dashboard, and I think it might be shared in the chat as well, we can click around and take a look. And what I've taken here are screenshots of the dashboard to share with you. So I'll give you a moment to click on the link if you're doing that, and then we'll get oriented to how Eau Claire Memorial High School's solar array is part of the climate solution, and think about how your school could be too.
If you're having trouble find it, it's in the chat, not the Q&A. It says link to map of solar dashboards in Wisconsin schools.
And Gina, could you put the direct link to Memorial's dashboard as opposed to just the map if that's not up yet, please?
Looks like the Claire Memorial, it looks like that one's already linked to. So.
Okay, awesome. All right. So if you're either live in the dashboard or looking at the shared screen here, we're looking at a snapshot on my screen of July 10th. And the reason I chose July 10th is that's Nikola Tesla's birthday, so why not use that as the day? We know where this data is coming from, what country it's in. We know the date that it was installed. I took the screenshot on October 15th, and we know the maximum energy that this system can be producing. But and as you scroll over the line, if this were live, the dot moves and it shows you at any moment in time how much electricity is being produced by that system. So at that point in time, at 2 p.m. on July 10th of this year, it was making producing 90.58 kilowatts. But when we aggregate the production over time, our units are then kilowatt hours. So on that one day, on July 10th of this year, the system produced 710 and about half kilowatt hours of electricity. If you're on the live screen, you can then click over to the month, and I'm just going to scroll down here. And oops, sorry, I'm looking at a different day. I forgot what I was doing here. So I'm looking the next day on July 11th. We have a really, really different curve here. So I'm going to go back. Here is July 10th, and you can see there are peaks and troughs in the curve. We can also take a look and see when the sun rose and when the sun set. So it rose about 5:45, but set about 8:30. Also on here, we're looking at the carbon emissions saved. So this is pounds of carbon dioxide that did not go up into the atmosphere because these solar panels are on the school. Now looking at July 11th, this curve looks really, really different. So what do you think changed between July 10th, where there were peaks and troughs, and this day where we have a very smooth curve? Any guesses? So if you were thinking it's because there were no clouds, you were spot on there. They had perfect weather in Eau Claire on July 11th, not so much on July 10th.
If someone asked, was it weather?
It was weather. You got it. And here is the second day that this system, so the system was installed but didn't actually get turned on until, it was installed in August, but it didn't get turned on until December, and that's a whole different conversation. But we can see that the days were much shorter in December. The sun rose just before 8, it set right after 4 o'clock. And also take a look at the y-axis. Here it goes up to 20K. Here it goes up to 100K. So you can actually fit this tiny little triangle of a curve right in here. So it goes right in there. So you got to pay attention as well to your axes in units when you're looking at your data. So a lot less, about 1/10 the amount of electricity was produced in December as in July of this year. We're going to move on over and take a look at how much electricity can be produced in a month here. And so on a monthly basis, we can see the aggregate amount or the total amount that was actually produced. And in April of this year, we can see the estimated amount was about 15.8 megawatt hours. But the actual amount, and because this isn't live for me, I can't hover and tell you, but it was 14.2. So the system produced less electricity than was anticipated. But there are other months where it produced more electricity than was anticipated. So this is really important because in that question that came in about how systems are paid for, part of it is when a system is making more electricity than expected, then that is essentially money coming back to the school, because these panels are tied into the grid and the school is essentially making electricity and selling it back to the utility company. So this is some other types of data that can be explored in seeing how your school building or any school building could be part of a solution. And in this example, Eau Claire Memorial High School is. And if you want to really dig into this data, if you're at the live dashboard, you can click up here and download the data and do analysis for yourself. Not only can you look at the production data, you can also look at the layout, which is really a fascinating thing to do if you're interested in solar. So this is the layout on the dashboard, and this is a drone view of the actual installation. You can see that they perfectly match each other. So each one of these panels that's on here is one of the panels that is actually installed on the roof. You could also, if you were at this drop down here, instead of looking at the physical layout, you could look at the logical layout of how the panels are all wired together. And you would see that they're all wired and they go through one inverter. So there's a lot that can be learned at a lot of different levels of inquiry if you're curious about how the technology works by exploring not just this solar dashboard, but other solar dashboards that were shared in that map with the blue dots earlier in the presentation. So finally, we're going to step in and step out and in this last part of the field trip, think about actions that you can take. So together we've been collecting data, analyzing some data from one Wisconsin school. And I'd like for you all to take a few minutes to think about how you can take action in your school or in your school district. And I have some suggestions for you. So first, remember, you are not playing a solo. You're not in this alone. We are all part of the solution if we choose to be. But we need to practice playing our instrument. So if you remember, I started off my career supporting sinks, where I was working on plant ecology and the protection and restoration of ecosystems. But because of my interests and my passions and coming to a deeper understanding of climate data, while I'm still continued doing the work, I shifted the focus of my work towards striving for the reduction of sources through the shifting of production and working to get schools to shift where they get their electricity from and enhancing the energy efficiency of their schools. And so really finding your passion and what you're good at is what's going to give you longevity in the long run. And what you do in your 20s might not be what you're doing in your 30s or 40s later on. As long as you're happy and love doing what you're doing, you're going to keep doing it and doing it with passion. And people are going to come and want to work with you on these things. So you are not alone. Just do what makes you happy is my first bit of action suggestion for you. But if you are feeling like working towards reducing the carbon footprint of your school is something you're really passionate about and you'd like to make happen, KEEP, where I work, offers mini grants to high school teams that are looking to have a small amount of money to take on a project to reduce their school's carbon footprint. And the link for that is being shared in the chat and can be shared with you later on, or you can contact me. And so I'd like for you to think about what is something you think your school can do to reduce emissions. And you can share that in the chat if you'd like, or you can just kind of think about it to yourself. I'll give you a moment.
Samara, while that's happening, I had a question. What does KEEP stand for and what is the mission?
Sure. So KEEP stands for Wisconsin's K-12 Energy Education Program. And our mission is to increase energy literacy across Wisconsin in an effort to reduce energy consumption. So we do that for us in KEEP, we do that by reaching teachers and students directly. And then our partners in the state are focused on energy, and they work with industry and the commercial sector and agriculture.
Awesome. That sparked a question. They said, do you only give grants to high schools?
Let me go back up here if I can. If you're at the connecting with me is really the first step. So if you have a really great idea and you're a student, then there is flexibility for sure. Because I know that there is a middle school team that has just this morning actually emailed me. They had a really great idea. So we're considering that for sure. So the answer is not just high schools. Connect with me or fill out from our website. The first step is to fill out a very short form of what your great idea is, and that'll start the conversation. Thank you. That's a great question. And very last poll question here. This is a list of the 4 fastest growing jobs in the US. In parentheses is a median annual salary. Which is the fastest growing job? What do you think?
And also, back to your original point, we did have one answer to how schools can be more green, and it was composting at school instead of food waste into landfills.
Yep, and that is absolutely true, and that is probably the biggest entry point for students and schools in general towards sustainability is reducing solid waste. And organic waste is really important because when those end up in the landfill, they are the source of methane, and methane is a very potent greenhouse gas. So that is a really fantastic objective to work on, is reducing solid waste from your school. All right, I saw some answers coming in, and the majority of them were for solar installers, and that is the fastest growing job in the United States this year. So if you're finding that you're excited by this, or maybe you came into us and joining this conversation because climate change is important to you, I want to share with you a couple of resources. One is this website where you can explore solar career maps. So this is not live right now, it's just a screenshot. But in the live version, you can hover on any one of these dots, and it can show you a pathway either through industry sectors of manufacturing, design, project development, and installations, as well as in a career trajectory. So it's a cool way to, and there's descriptions of each of the dots. So it'll open up a pop-up box and describe what that kind of a job is. And also at KEEP, we have partnered with Slipstream and produced a video series. There's 6 videos in here that are specific to clean energy jobs here in Wisconsin. So if you're thinking about what your classes in high school should be next year, or even considering what a major or minor in college might be in college, there are some ideas that you might be interested in exploring through this video series here. So that brings me to the end of our field trip here. And I'd like to say to you all, shukran, merci, gracias, and thank you. And if there are any other questions in the time remaining, I'd be more than happy to answer them.
Yeah. No, that was perfect timing. Thank you so much for presenting today. And Gina, thank you for, on the back end, being able to share all these links. I hope everybody is able to get to them and save them to check them out at their own time. And yeah, for our closing, thank you everyone so much for joining us at the Wisconsin Science Festival. Thank you to our field trip presenters, Samara and Gina. A recording of this field trip may be available, and we will follow up with teachers about that. Remember that the Wisconsin Science Festival continues with events hosted from organizations across the state that you can participate in. Just check out wisconsinsciencefest.org for more fun science. Thank you, everybody.
Bye-bye. Thank you.
Bye.